Myself is Prabhakar for BSc Electronics first semester, University of Mysore. This is the first session. In this session, I will explain the Kirchhoff's laws. Before that, you must know about some terms. All electronics networks contains electronic components. The electronic components are classified into two types. One is active components and second one is the passive components. Active components are those components process themselves and perform functions like rectification, amplification, etc. Example, voltage or current sources, semiconductor diode, transistors, etc. Passive components are those components they cannot process themselves and cannot perform functions like rectification, amplification, etc. But they absorb or store the electrical energy. Example, resistors, capacitors, inductors, etc. The active components are non-linear and unilateral, but passive components are linear and bilateral. And next, you must know about the different electric circuits according to their properties. Linear, the circuit in which the current is proportional to the voltage is called linear circuit. Example, circuit containing the elements like resistors, capacitor and inductors, etc. The circuit in which the current is not proportional to the voltage is called nonlinear circuit. Example, circuits containing diodes, transistors, etc. Next, unilateral network. It is a circuit whose properties change with the direction of its operation. A diode rectifier is a unilateral circuit because it cannot perform rectification in both directions. Next, bilateral network. A bilateral network is one whose properties are the same in in either direction. The usual transmission line is bilateral because it can be made to perform its function equally well in either direction. Next, network. A circuit is having number of circuit elements is called a network. Node. Node is a junction in a network where two or more circuit elements meet at a point. That means two or more circuit elements connected together. Next, mesh. It is a loop that contains no other loop within it. Next, network topology. In this network, there are three nodes A, B, E and two independent loops A, B, E, F, A. This is the one loop, first loop. Second loop, B, C, D, E, B. This is the second loop. And next, this network having four branches AB, BC, BE and AF. Actually, this network consists of three nodes, four branches and two independent loops. A network with n nodes, L independent loops, B branches will satisfy the fundamental theorem of network topology. B equals L plus n minus 1. You know the B means branches equals 4, and L is the independent loops, that's equals to 2. It's having 2 loops. N equals to 3, the network having 3 nodes, minus 1, that's equals to 4. That means it satisfies the fundamental theorem of network topology. Next, Ohm's law. This law applies to electric conduction through good conductors and may be stated as the ratio of potential difference V between any 2 points on a conductor to the current I flowing between them is constant, providing the temperature of the conductor does not change. In other words, V by I equals to constant, or V by I equals to R, where R is the resistance of a conductor between the 2 points considered. Next, Kirchhoff's laws. In the Kirchhoff's laws, there are 2 types of Kirchhoff's laws. First one, KCL, I mean Kirchhoff's current law, and second one is the Kirchhoff voltage law. The first one, Kirchhoff current law. The sum of currents entering and leaving a node in a circuit is equals to 0. That means summation of I equals to 0. In the network, in the circuit, let I1, I2, I3 and I4 are the currents at a junction or node are 0 as shown in the figure. The currents flowing towards the junction are taken as positive. That means the current flowing towards the junction means I1 and I2 is going towards the junction, is flowing towards the junction. I1 plus I2, and those currents flowing away from the junction are taken as negative. That means I3 and I4 are going away from the junction. That means I3 and I4 are going away from the junction. That means we must take negative. So I1 plus I2 minus I3 minus I4, that's equals to 0. That's equals I1 plus I2, that's equals to I3 plus I4. Thus, at a junction of a network, the sum of the currents flowing towards is equals to the sum of the currents flowing away from the junction. Next, Kirchhoff's voltage law. In any closed mesh, the sum of voltage drops is equals to the sum of all EMFs in the circuit. That means summation of IR, that means the product of current and resistance, is equals to the summation of EMFs E. In the mesh, in the circuit, in the mesh, that means mesh means A, B, C, D, A is a mesh. Before that, you must know about the sign conventions used to apply the KVL to the mesh. The fall in potential in the resistor is taken as negative. The rise in potential is taken as in resistor is taken as positive. The rise in potential in voltage source is taken as positive. The fall in potential in voltage source is taken as negative. I am starting from A, I1 into R1. The voltage drops across R1 is I1 into R1 minus I1 into R1. Next, minus I1 into R1 means the fall in potential plus to minus the fall in potential in resistor is taken as negative, minus I1 into R1 minus I2 into R2, the same thing, minus I3 into R3 plus E means the rise in potential in the voltage source from negative to positive, you must take positive. That's equals to 0. Therefore, I1 into R1 plus I2 into R2 plus I3 into R3, that's equals to E. In the source voltage is taken as positive while moving from the negative terminal to the terminal of the battery to the positive terminal because of the rising potential. Next, application of Kirchhoff's laws. Using Kirchhoff's circuit laws, the various voltages and currents circulating around a linear circuit can be found. Next, we can also use loop analysis to calculate the currents in each independent loop by using Kirchhoff's laws. Thank you.